Good evening, ma'am.
Good evening, sir. You can continue, sir.
Ma'am, make me the host, ma'am.
Yes, sir, I'm doing.
Okay. Good evening, students.
Good evening, sir.
So we'll continue. Let others join later. I think we have done 9 questions in the last class, I believe. I think so, yes?
Yes, sir.
We will continue from the topic. A lot of questions to be done and a few more topics from this chapter. We have a lot of questions we need to work on this electrochemistry chapter. Let's see. Now, I defined what is electrochemical series. Electrochemical series. This electrochemical series is also called as activity series. Is also called as activity series. What is this electrochemical series? Arrangement of electrodes in the increasing order of their standard reduction potential. The standard reduction potential is abbreviated as what? SRP is called as electrochemical series. Arrangement of electrodes in the increasing order of their standard reduction potential is called as electrochemical series. Now, few of the electrode system I remember, we will try to understand that lithium electrode, lithium rod in lithium ions will be called as lithium electrode. It has minus 2.37 volts. Aluminium electrode, Al metal in Al3 plus, it has minus 1.66 volt. Zinc electrode, Zn2 plus, giving you that's minus 0.76 volts. Hydrogen electrode, I told you how do we represent hydrogen electrode, all that in detail. It is a 0.0 volt. Hydrogen electrode potential, we assumed it to be what? 0. Now, silver electrode, Ag plus, it is 0.80 volt. Now, before that, maybe I should write copper, Cu2 plus, it is plus 0.34 volt. And gold electrode, Au3 plus, it is around 1.5 volt. And we have fluorine electrode, it will be around 2.31 or 73 volts. I don't remember the value. These all are in plus sign, remember. Now, in the electrochemical series, lithium ion or lithium electrode is placed on the top, fluoride electrode placed is at the bottom, fluorine electrode is placed at the bottom, and in the middle, hydrogen electrode will be placed. Hydrogen electrode will be placed because the potential of hydrogen electrode is 0, therefore hydrogen electrode will be placed in the middle. The electrodes which are placed above hydrogen, they act as a very good reducing agents. They act as a very good reducing agent. What do you mean by a reducing agent? Any metal which undergoes oxidation will be called as a reducing agent. So all these electrodes which has negative potential, they will undergo oxidation very easily. Therefore, they are all called as reducing agents. Electrodes which are placed below, they are all called as good oxidizing agents. Why they are called as good oxidizing agents? Because they will undergo reduction easily. So electrode hydrogen is placed at the center. So the electrodes which are above hydrogen, they're all called as very good reducing agent because they undergo oxidation. Anything which undergoes oxidation, any electrode which undergoes oxidation will be called as reducing agent. Anything which undergoes reduction is gain of electrons, will be called as a oxidizing agent. Now electrodes below hydrogen, positive potential, all will undergo reduction easily. Therefore, they are all called as oxidizing agents. Now, the 10th question here, what we are supposed to understand is this. The standard electrode potential E0 value of aluminum they have given. They have given for silver, they have given for potassium, and also they have given for chromium. Now, for aluminum, what they've given? Aluminum, it's minus 1.66 volt. For silver, it is 0.80 volt plus 0.80 volt. And for potassium, they have given as minus 2.93 volts, and for chromium Cr3 plus to Cr, they've given it as minus 0.74 volts. They're asking you the correct decreasing order of their reducing power. Correct decreasing order of their reducing power. Larger negative value will be strong reducing agent. See here, larger negative value. Lithium has a larger negative value amongst these three. Therefore, the strongest reducing agent will be lithium. Amongst this, which is the strongest reducing agent? Amongst this, potassium has negative value, minus 2.93. Therefore, this will be the strongest reducing agent, potassium. After potassium, it will be aluminum because minus 1.66 value. And then it is chromium, and then it is silver. Therefore, the answer for this question will be option B. Potassium is greater than aluminum, aluminum is greater than chromium, and chromium is greater than silver. You should remember, larger the negative value, stronger will be the reducing agent. So amongst this four, the larger negative value is for potassium. Therefore, potassium is the strongest reducing agent amongst them. Next is aluminum, next is chromium and silver. Did you understand this question? Answer is option B. Did you follow this question?
Yes, sir.
The next question, we'll have to work a lot of questions possibly today. All right. The next question, consider half cell, what's that? Consider the half cell reduction reaction, Mn2 plus 2 electrons giving you Mn. So this is gain of electron is reduction. And the electrode potential E0 is 1.18 volt. It is minus 1.18 volt. This minus sign is missing here. It is minus 1.18 volt. And Mn2 plus loses an electron and gets Mn3 plus, and the electrode potential is minus 1.5 volt. The E0 of the reaction, the overall reaction, Mn2 plus giving you Mn0 and Mn2 plus. Let's just observe this reaction firstly. Mn2 plus and giving you Mn0 plus Mn2 plus. I have not balanced the reaction. We will balance the reaction because it's given here, we'll balance. Now, Mn plus 2 to Mn plus 2 to plus 3. This should be plus 3. This is plus 3. This is plus 3. This is oxidation. Plus 2 to plus 3. Increase in charge, it is oxidation. Here it's plus 3. It is not plus 2. Wrongly typed. All right. Now here, from plus 2 to 0, there's a decrease in charge. It's called as reduction. So a metal, you can see it's undergoing reduction as well as it's undergoing oxidation. So these kind of reactions are called as disproportionation reaction. These kind of reactions are called as disproportionation reaction. What do you mean by disproportionation reaction? A reaction in which an element undergoes both oxidation and reduction will be called as disproportionation reaction. So we will balance this equation, 3Mn2 plus giving you Mn0 and 2Mn3 plus. The reaction is balanced now. Now the question is, the possibility, and they're asking the E0 value for the reaction, the overall reaction, and the possibility for the forward reaction. What are the first reaction they've given? The first reaction is Mn2 plus 2 electron giving you Mn, and E0 value they've given as minus 1.18 volt. The second reaction is 2Mn2 plus giving you 2Mn3 plus 2 electrons. And E0 value here is minus 1.51. So on adding these two equations, when you add these two equations, what happens? Now these two electrons and these two electrons will get cancelled. What you have? 3Mn2 plus, giving you Mn plus 2Mn3 plus. It's the reaction. This is the reaction what they've given you. So on adding these two equations, you get the overall reaction. Now, what will be E naught value for this? E naught value, when you add these equations, you will get minus 2.69 volt. So E naught value is negative here. When E naught value is negative, we know the relation free energy delta G is equal to minus NF E naught. Since E naught value is negative, what happens? It's minus NF into minus 2.69. So you will get the value NF 2.69. That means delta G value, you are getting it as positive. Free energy value, you are getting it as positive. When free energy is positive, it is called as a non-spontaneous reaction. When free energy is negative, then it's a spontaneous reaction. When free energy is positive, it is called as a non-spontaneous reaction. So when we say it is a non-spontaneous reaction, the reaction will not proceed forward reaction by itself. So we need to supply some kind of energy. So forward reaction is not possible because it's a non-spontaneous reaction. If delta G is negative, then the forward reaction will be possible. So in this case, delta G is positive. Therefore, it is called as a non-spontaneous reaction. When we say non-spontaneous reaction, forward reaction is not possible. Hence, the answer for this question is option D, 0.269 volt, and the reaction is not possible. Therefore, it is written as what? No. They're asking the possibility of forward reaction, respectively. The forward reaction is not possible. Therefore, we have written it as no. Did you understand this question? Option D, ma? Oh, yeah. Okay. What's that? Oh, it's become no. E naught is negative only. No. Delta G is positive. Delta G is positive. Free energy has a value joules. Delta G is in joules. It's in positive. But you can see they've given you here in volts. So that means they've given you electrode potential value. Don't get confused. Free energy, delta G is what? Free energy. Free energy will have the unit in what? Joules. Energy, the unit is in what? Joules. Here you can see they have given E naught values. All these are because they've given you in what? Volts. So E naught, what we calculated here, it is minus sign. E naught is negative, but still it's 2.6. It's wrongly typed again here. It is 2.69 minus 2.69 minus 2.69 volt. And delta G is positive. When delta G is positive, it's what? Non-spontaneous. But here the value is what? Negative, E naught value, because they have given you in volts. Do not get confused. Understood then, Lakshmi, what I'm telling?
Yes, sir.
Yeah. Therefore, the reaction will not take place. Therefore, the option is D. It is 2.69 minus 2.69. When I was typing, I would have overlooked and a lot of mistakes is happening. All right. So did you understand this? Other students followed? Tanushri, Rishika, are you there? All right. A solution is 1 molar in each sodium chloride, cadmium chloride, zinc chloride, and lead chloride. To this, tin metal is added. Which of the following is true? See, the solution is 1 molar each, sodium chloride, cadmium chloride, zinc chloride, and lead chloride. To this, tin metal is added. Given electrode potential of lead is minus 1.26 volt, electrode potential of tin is minus 1.36 volt, cadmium minus 0.40 volt, zinc minus 0.763 volt, and sodium minus 2.71 volt. A solution of 1 molar each, sodium chloride, cadmium chloride, zinc chloride, and lead chloride. To this, tin metal is added. Which of the following is true? Now we have solutions of lead we have, and the potential is minus 0.126 volt. And we have cadmium ions. So cadmium ions, it is, they've given what's the potential for cadmium, minus 0.40. And then we have zinc ions, zinc electrode. Zinc, they have given the electrode potential to be minus 0.76. And you have lead, Pb, lead ions, and the potential for lead, what they've given is minus, lead I've given you here. Sodium, we will take. So here it should be sodium first. Sodium ion, they've given you sodium ion. What's the potential for sodium ion? Minus 2.71 volt. In all this, what has been added? In all these, tin is being added. Tin. So the electrode potential of tin, you can see it is minus 1.36. Now they're asking which of the following is possible. Which of the following is possible? Before we answer the question, all right, the lead should be in the fourth place. So because as per the sodium, cadmium, zinc, and lead is here. It is minus 0.126 volt. Now in all this, tin is added. So what happens? When tin is added to sodium ions, what will happen? Will there be any reaction? Yes or no? Will there be any reaction? Now you see sodium is having the negative potential minus 2.71 volt, and zinc, tin is having a potential minus 0.136 volt. Now which is a strong reducing agent here? Larger the negative potential is a strong reducing agent. Tin is a stronger reducing agent compared to what? Sodium is a stronger reducing agent compared to what? Tin.
Tin.
Therefore, reduction of sodium is not possible by tin. Reaction will not take place. Similarly, you can see here in cadmium also. Cadmium is having negative potential is more compared to tin. So reaction will not take place. Zinc also has higher reduction potential than tin. Therefore, no reaction. But if you observe lead is minus 1.26, minus 0.126, and tin is minus 0.136. So zinc is having larger potential compared to what lead. So when tin is added to lead solution, what happens? Tin is better oxidizing agent because minus 0.136, and here it is minus 0.126. Therefore, tin will reduce what? Lead. You will get lead and tin will be oxidized. This reaction will take place. So this the chart you can see lead is reduced to Pb. Therefore, the answer for this question is option D. Do you understand this question? Did you follow this?
Yes, sir.
See, larger the potential, greater is the reducing agent. Larger the negative potential, greater the reducing agent. So here, tin is having larger negative potential only compared to what? Zinc. Therefore, and only compared to what? Lead. Therefore, tin will reduce only lead, not other ions. Hence, the answer for this question is option D. All right. The next one, for the cell reaction, Fe3 plus aqueous plus 2I minus aqueous, giving you 2Fe2 plus aqueous plus I aqueous. See, this is a redox reaction. Ion is getting reduced. We will write this equation 2Fe3 plus 2I minus, giving you 2Fe2 plus I. So Fe3 plus to Fe2 plus, it is reduction. I minus 1 to 0. So this is oxidation. So iodine is getting oxidized. Iodide is getting oxidized. All right, and ion is getting reduced. Each knot cell is 0.24 volts at 298 Kelvin. The standard Gibbs equation of the cell reaction is, they have given the Faraday's constant. Now we know the relation delta G naught is equal to minus NF E naught. Minus NF E naught. What is N? In this case, N is equal to 2. Why? Because Fe3 plus 2 plus. There is 1 electron gained. Here also minus 1 to 0, 1 electron lost because this is oxidation. Totally 2 iodide ions are there. So therefore, total number of electrons is 2. Since total number of electrons is 2, minus 2 into 96,500, and E naught value, they've given it as 0.24. So on simplification, we will get this value as minus 46,320 joules. That will be equal to minus 46.32 kilojoules. Hence, the answer for this question is Option B, minus 46.3432 kilojoules. This relation you should know. Minus NF E naught. Minus NF E naught. E naught is standard electrode potential. E naught is standard electrode potential. The relation between standard free energy change and electrode potential. Followed?
Yes, sir.
The electrode potentials of copper, Cu2 plus aqueous plus electron, giving you Cu plus, its reduction, and Cu plus plus electron, copper, it's also reduction, are 0.15 volt and 0.50 volt respectively. The value of E naught of copper 2 plus to copper is, see, copper 2 plus plus an electron giving you Cu plus. It's a reduction from plus 2 to plus 1, reduction. So they have given you E naught value. We'll write as E naught 1 as plus 0.15 volt. Therefore, delta G naught 1 will be equal to minus N1 E naught 1 and F. Faraday's constant. We'll keep it as such. We know that delta G naught is equal to minus N F E naught. That is what this is. Second equation, Cu plus an electron gives you C. So E naught 2 will be given as 0.50. Therefore, we can write delta G naught 2 will be equal to minus N2 E naught 2 and F. It's a representation. Totally, delta G naught will be equal to delta G naught 1 plus delta G naught 2. So total free energy change will be equal to sum of these things. When I say the sum of these things, we can write minus N E naught F is equal to minus N1 E naught 1 F plus of minus N2 E naught 2 F. I'm just adding these two equations, equating, that's all. So what happens? Now, N is 2. Totally two electrons are there. When you add these 2 electrons, so it will be minus 2 E naught F. That will be equal to, here it is what? 1. In the first equation, only 1 electron. Minus 1, I'm not writing. E naught, they've given us 0.15. Its plus value, since it is minus, I can write it as minus. Plus of here, it is minus 1 again. E naught, they've given us 0.50 into minus, here they've given us what value? Plus, no? So this will become again minus of 0.50. So this is again Faraday, and you have to write here also Faraday. F should be included. So what happens? So here it will be simplification. Minus 2 E naught F is equal to minus 0.15 Faraday minus of 0.50 Faraday. So it will be minus 2 E naught F is equal to minus F. If you can take common, F as common, so you'll get a 0.15. Minus into minus, it becomes plus 0.50. So F and F will get cancelled. F and F will get cancelled. On simplification for E naught, you will get E naught to be 0.65 divided by 2. It is 0.325 volts. It's only mathematics. The rest of the thing is mathematics. The answer for this question, they're asking the value of E naught will be totally. So the total E naught value will be 0.325 volt. Hence the answer for this question is option A. Did you follow this working? Students, did you follow this working? Dhanlakshmi, Tanushree,
Yes,
yeah, followed. Others? Yeah, okay. Vaishnavi, okay, God bless you. You don't answer me, right? Yeah, Vaishnavi, yes. Tanushree. The next question, the 15th question. A hydrogen gas electrode is made by dipping I explained what is hydrogen electrode in detail. Standard hydrogen electrode, I explained few classes before. So hydrogen gas electrode is made, yeah, Dhanushri, good. A hydrogen gas electrode is made by dipping platinum wire in a solution of hydrochloric acid. Platinum wire in a solution of hydrochloric acid at pH 10. At pH 10. And by passing hydrogen gas around about platinum wire, 1 atmospheric pressure. They've given the pressure of hydrogen gas to be 1 atmosphere. The oxidation potential of the electrode would be, they're asking the oxidation potential of the electrode. Now, for hydrogen electrode, oxidation half cell reaction. Oxidation half cell reaction is H2, pressure is 1 atmosphere, gives you 2H plus 2 electron. Now this is H plus ion concentration. So when we say H plus ion concentration, you can see they've given pH value, they've given to be 10. pH is given to be 10. Now if pH is 10, what is hydrogen ion concentration? Now we know that pH is defined as negative logarithm to the base 10 of H plus ions. Now they've given you pH to be 10. So you can find the H plus ion concentration. What will be the H plus ion concentration? The H plus ion concentration will be, if you take the log to the left hand side, it will be anti-log of 10. So anti-log of 10 is 10 to the power minus 10. Remember, anti-log of 10 is 10 to the power minus 10. That means the H plus ion concentration is 10 to the power minus 10. This is the concentration of H plus ion. Now we should know the Nernst equation. We were talking about Nernst equation in the previous classes. The Nernst equation, E cell is equal to E naught cell minus 0.0591 divided by 2 log of H plus ion concentration to the power 2 divided by pressure of hydrogen. See, why H plus ion concentration to the 2? Because the reaction you can see, 2 H plus ions. So therefore, the coefficient of hydrogen ion is 2. Therefore, we raise it to the power 2. So what will happen? E naught of the cell. For hydrogen electrode, E naught cell is how much? 0. For hydrogen electrode, E naught of hydrogen is equal to 0 volts. E naught of hydrogen is equal to 0 volt. Therefore, what happens? E cell will be equal to minus 0.0591 divided by 2 log of H plus ion concentration. What we found? 10 into 10 to the power minus 10 the whole square divided by the pressure is 1 atmosphere. So on simplification, we will get 0.0591 log 10 to the power 10. Log 10 to the, see, both are same. Base is same, the other one is same. This is also same. So the value will be what? 10. You can write log AB, log A to the power B as what? We can write B log A. So log 10 to the power 10 can be written as what? 10 log 10. Log 10 value is 1. So 1 into 10 becomes 10. So that is what this means. Therefore, it will be 0.0591 into 10. It will be equal to 0.591 volt. Not 0.0591. It is multiplied by 10. Therefore, it is 0.591 volt. Hence, the answer for this question is option B. Did you understand this question? Students, did you follow?
And yes,
Yeah.
sir.
Yes. So today we'll work out a few more problems based on this concept. See, a lot of formulas we're introducing, a lot of different methods of working the problems. So you should concentrate and, catch up the point so that it will be easy for you to work other problems. When you practice, it will be easy for you. Right. The next question here is the pressure of hydrogen required to make the potential of hydrogen electrode 0 in pure water at 298 Kelvin is. The pressure of hydrogen required to make the potential of hydrogen electrode 0 in pure water at 298 Kelvin is 10 to the power minus 12 atmosphere, 10 to the power minus 10 atmosphere, 10 to the power minus 4, or 10 to the power minus 14. So we know that the reduction reaction, 2H plus 2 electrons giving you H2. This is reduction. This is reduction. According to Nernst equation, E is equal to E naught minus 0.0591 divided by 2 log of pressure of hydrogen gas divided by concentration of H plus the whole square. So the E naught of hydrogen electrode, we know it is 0. 0 minus 0.0591 divided by 2 log of pressure of hydrogen gas divided by hydrogen ion concentration. Now, hydrogen ion concentration, you should remember, for pure water, it's 10 to the power minus 7 moles. Because we know that water will dissociate to form H plus and OH minus ion concentration. So H plus and OH minus ion concentration will be equal to H plus into OH minus concentration is 10 to the power minus 14 mole square per decimeter cube. Therefore, the H plus ion concentration will be 10 to the power minus 7. Remember this. So it will be 10 to the power minus 7 the whole square. Excuse me. For the question they've given you, for making the hydrogen electrode potential to be 0, what is the pressure required? We're supposed to calculate the pressure required. That means this E, we have to equate it to 0. When we equate it to 0, then pressure of hydrogen gas should be equal to the concentration of H plus the whole square. That is 10 to the power minus 14 atmospheres. So 10 to the power minus 14 atmospheres. This should be equal to 0. Only then what happens? When this and this is same, what happens? Log 1 you get. Log 1 becomes what? 0. When log 1 becomes 0, the electrode potential becomes equal to 0. So we'll write it as E only here. If the electrode potential has to become 0, then the pressure of hydrogen gas should be equal to the concentration of hydrogen ions as per this equation. So 10 to the power minus 7 the whole square is 10 to the power minus 14 atmosphere. So hence the answer for this question is option D. I hope you followed this problem. Yeah?
Sir.
Yes. The next question. The standard electrode potential of stannic to stannous SN4 plus stannic to SN2 plus stannous couple is 0.15 volt, and that of chromium 2 plus to chromium couple is minus 0.74 volt. Standard state are connected to make a cell. The cell potential will be, listen to this. This tin, they've given the potential to be 0.15 volt, and chromium couple, they've given the potential to be minus 0.74 volt. They're asking you the cell potential. Cell potential or EMF of the cell is given by the formula E naught of anode, not E naught of anode, E naught of cathode minus E naught of anode. E naught of right-hand side electrode minus E naught of left-hand side electrode, or electrode which undergoes reduction minus electrode which undergoes oxidation. So you should, we don't know which is undergoing oxidation and reduction here. You should remember this point: larger the potential, the electrode will undergo reduction. The electrode will undergo reduction. So amongst these two, which is larger? Tin is 0.15, it's a positive value, and chromium is minus. Therefore, tin will undergo reduction and chromium will undergo oxidation. So in these kind of questions, you should remember the electrode with larger potential will undergo reduction. Electrode with lesser potential will undergo oxidation. So it will be E naught of tin minus E naught of chromium. That is equal to 0.15 minus of minus 0.74. That will be equal to 0.89 volts. So answer for this question will be option A, plus 0.89 volt. Followed with this? Yes. Students, you followed?
Yes, sir. Follow.
Yes. Yes. Why others have left? Only Dhanalakshmi is there. Nobody is there. Dhanalakshmi, others have left because I'm asking questions. Huh? Okay. Now we'll work this problem. See, this is the reverse of the problem which we worked earlier. I don't know whether you remember. Let's see. Given Cu2 plus 2 electron giving you copper, it's a reduction reaction. E naught is 0.337 volt. Second equation, Cu2 plus an electron giving you Cu plus, E naught is 0.153 volt. Electrode potential, E naught for the reaction, E plus electron giving you copper will be. Now we know that delta G naught is equal to minus NF E naught. For the reaction, Cu2 plus 2 electrons giving you Cu. This is marked as equation 1. What will be delta G naught value for this? Delta G naught value will be minus 2 into F into E naught. What is that E naught they've given? 0.337 volt. Now, similarly, for the reaction, Cu plus giving you Cu2 plus an electron. This is a reduction equation. This is oxidation again from +1 to +2. It is second equation. They have given you delta G naught is equal to minus 1 into F into 0.153 volt. Minus 0.153 volt. Now just observe here, Cu2 plus electron giving you Cu plus. It is plus value. If you reverse the equation, what happens? The electrode potential becomes negative. That is why I've written here minus sign. Did you understand? See the reaction. This is reverse. Here what they've given, Cu2 plus electron giving you Cu plus. What I've written, Cu plus giving you Cu2 plus electron. I've reversed the equation. When I reverse the equation, the potential gets reversed. That's why I've taken minus here. Did you understand this?
Yes, sir.
So therefore here it will be what? Plus 0.153 F. So adding equation 1 and 2.
Sir, joules na, sir.
Illama, Faraday. See this Faraday, this F is here, no? It is delta G naught.
Yes, we haven't substituted F, sir.
Yeah, I didn't substitute the F. I've just maintained the sub-value F. Here also F I've maintained like this only. This F
Yes,
it
sir.
is. So adding equation 1 and 2. Adding equation 1 and 2, we get. When we add equation 1 and 2, what we get? Cu2 plus 2 electrons giving you Cu. Cu plus giving you Cu2 plus an electron. So what happens? One electron will get cancelled. So what you will get? This Cu2 plus and this Cu2 plus also will get cancelled. So you will get Cu plus an electron giving you Cu. So this is the required equation. We are getting it. So that means we have to add both. Delta G naught will be equal to minus 0.521 F. So this is the value. So when you add these two values, you will get delta G naught to be is minus 0.521 volt. 521 F. So we know delta G naught is this. They're asking you to calculate what? E naught value. So we know the relation delta G naught is equal to minus NF E naught. So what is E naught now? E naught will be equal to delta G naught minus NF. So that is minus 0.521 F divided by N is 1 electron, 1 into F. So what happens? This F will get cancelled. So what is that value will get? We will get minus NF E naught. So this is minus NF E naught. And delta G value is already negative here. So this minus also will be here. So minus and minus will get cancelled. So you'll get 0.521 volts. Hence the answer for this question is option A. Got it?
Yes, sir.
Yeah. Then Lakshmi, one more problem will work, one or two problems, and then we will try to stop it. Two problems, we'll finish off this. On the basis of the information available from the reaction, 4/3 Al plus O2, giving you 2/3 Al2O3. Delta G value is minus 827 kilojoules per mole of oxygen. Kilojoules per mole of oxygen. The minimum EMF required to carry out the electrolysis of alumina is minimum EMF required. Now, if you observe this equation, now they are giving 12 electrons plus 6 O2 minus gives you 3 oxygen molecule. So as per this reaction, 6 O2 minus ions has to accept 12 electrons. Only then you get reduced to oxygen. Likewise, 4 Al3 plus gives you Al plus 12 electrons. Each aluminum gives 3 electrons. Since we have 4, it gives you 12 electrons. So therefore, 4/3 Al3 plus ions gives you 4/3 Al plus 4 electrons. So this is 4. If you divide by 3, because as per the given equation, it's 4/3 aluminum ion. So divide by 3, the whole equation, when you divide by 3, you get 4/3 Al3 plus gives you 4/3 Al plus 4 electron. That is 4 electron plus 2 O2 2 minus gives you 1 mole of oxygen. 1 mole of oxygen. This is for 3 moles. This reaction is not given in the question. We should understand that in order to get 3 moles of oxygen, how many moles of electron is required. So that's the hint here. So for 1 mole of oxygen, how many electrons is gained? 4 electrons. Now what is delta G value? Delta G value is minus NF E naught. So delta G value they've given to be minus 827 kilojoules they've given. Therefore, it's 10 to the power 3 joules. That will be equal to minus 4. N is 4 electrons. F is 96,500 into E naught. So when you simplify for E naught, I'll write it here. E naught will be equal to minus 827 into 10 to the power 3 divided by minus 4 into 96,500. So on simplification, we will get the value to be 2.14 volts. So the answer for this question is option A, 2.14 volts. Right? Followed? Last
Followed,
question
sir.
all for today, and then we'll continue with the next topic. Fuel cells we have to do, and we have to do rusting, all that. Questions based on the E naught for zinc cell, Zn2 plus aqueous, copper 2 plus copper. This is nothing but what cell? Daniell cell. We learned Daniell cell in the beginning. The electrode potential of Daniell cell, you should remember it's 1.10 volt. Right? What they've given? Zn giving you Zn2 plus. So if I write the half cell reaction, it will be this. And copper 2 plus gains 2 electrons to give copper. So when you add overall reaction, these 2 electrons will get cancelled. Zn plus CO2 plus giving you Zn2 plus copper. For this reaction, they have given you E naught to be 1.10 volt. 10 volt. Now they're asking what is the equilibrium constant. Now equilibrium constant is E naught is equal to 0.0591 divided by n log to the base 10 of K equilibrium. At equilibrium, you should remember at equilibrium, E naught of E cell is equal to 0. E cell is equal to 0. When we say E cell is equal to 0, that is why we have written this. because E cell is equal to E naught minus 0.59. You should remember this equation, Nernst equation. E cell is equal to E naught minus 0.0591 divided by N log of equilibrium constant. Since E cell is 0, this becomes 0. Then I take this E naught to the left-hand side. Therefore, this equation you get. N is number of electrons. Now, here in this, Zn to Zn, 2 electrons involved. N is 2. And 2. Therefore, what will be this? E naught they have given to be 1.10 volt. So 1.1 is equal to 0.0591 divided by 2 log to the base 10 of K. So on simplification, log to the base 10 of K equilibrium will be equal to 2.20 divided by 0.0591. On simplification, log to the base 10 of K equilibrium is equal to 37.225. So K equilibrium will be equal to anti-log of 37.225. That will be equal to 1.66 into 10 to the power 37 minus 37. Hence, the answer will be of the range 10 to the power minus 37. Kindly find out how to take the anti-log values. All right, it's difficult to learn from the math teacher or the school physics teacher. They'll teach you how to find the anti-log. Then Lakshmi, only you are there. We will stop the class. We'll meet later.
Yes,
All right.
sir.
Thank you.
Yes,
Ma'am.
sir.
Thank you.
Thank you, sir.